you for the introduction. So we would like to present today the Eclipse IoT-Testware. It's, let's say, the first time where we really just talk about this one because it's coming out of a project, a German project, and today we want to talk about just about the IoT-Testware. Just a short introduction. My name is Sascha Hackel. I'm from Fraunhofer FOKUS. It's a research institute in Berlin. And yeah, my project colleague, Alexander Kaiser, he's from Relayr and a startup in Berlin. And yeah, we are working closely together on the IoT-Testware. Just a short introduction. We want to talk about our motivation, the challenges in IoT. It will be just a short part because I guess everyone is knowing about what challenges we face in IoT testing and in testing in general. And then the main part will be the IoT-Testware. We will present the IoT-Testware. We will give some use cases of the IoT-Testware. And at the end, Alex will also give a short demo about the IoT-Testware. So yeah, we will give you any information on the hand about the IoT-Testware. So let's start with the first part. We see that there is a big discrepancy between the ICT and OT that we want to, let's say, we want to tackle. Because in ICT, software is nothing new. We have security and privacy we concerned about. It's highly dynamic. So you can see there are some, let's say, characteristics about the ICT. And in contrast, let's say, is the OT. We have isolated networks. We have normally, so let's say in the past, no connection to the internet, robustness. We have real-time requirements and a lot of more. And we see that the IoT could be, let's say, something that connects both worlds because IoT relies on both sides. So we have devices, we have the, let's say, traditional industry devices that work and will now connect to the internet to whatever, transmit data, to get insights from those data. And yeah, IoT testing is mostly, if you see some surveys, mostly about security concerns. So we also need to tackle this. And what we see in IoT-Testware, what we started with, let's say, are actually the three main bubbles you can see here. So we started with protocol testing in IoT-Testware. We have conformance testing first, on that interoperability testing, and then performance testing, as you know, protocol testing. Then, of course, we are looking at system testing, unit testing, integration, stuff like that. We see all those, let's say, known things coming together and creating or defining the IoT testing. So for us, it's nothing. IoT testing is nothing new. So it's nothing new to consider, but it's something like a set of things we already know, but we have to put it together and have to work together with the different areas of testing. Now, just a short word how this IoT-Testware was initiated, and after this we want to talk about the IoT-Testware in general. So, as I said, it was initiated by a German-founded project called IoT-T. So we had the, let's say, scenario that some organizations like Relayr and Audi had some requirements. So Audi, coming from manufacturing background, and Relayr, a startup who, let's say, provides cloud infrastructures. They have different requirements on IoT and IoT quality and testing. So they asked us as, let's say, academic institutes and our colleagues from Fraunhofer IPK to think about new methods of IoT testing, to think about what is the challenge, how we can solve and fulfill the requirements of the industry. So we created some, we found some insight, we created some method, what I said in the slide before, we saw IoT testing is nothing new, but we need something that, let's say, put all the stuff in a box, like security and conformance and protocol testing, and create something the industry can work with. So our goal was also to give those tools, those methods to a certification body. So because the industry wants something to say, my IoT device is tested, or my IoT device is secure, or whatever. So it's like a closed circle now. We have our methods, our output that can used by certification bodies. In this project it was DEKRA, and the industry can rely on that. That was the initial plan about the project, and during the process we found out we need something to provide, not just saying, okay, IoT testing is nothing new and you go make security testing and conformance testing. We wanted to provide something, and that's why IoT-Testware was born. And we are really happy that the Eclipse Foundation was, let's say, put his arms around us, because it was something new for us. It is our first project that we initiated and working on at Eclipse Foundation. And the next interesting part of this was that we just only want, let's say, a technical solution, a testing solution. We want also some standards, because certification bodies like DEKRA, they want to also rely on standards. They just can't say, okay, you get your certification here, but it's because we think it's okay. They need to refer to something, and that's why we could, let's say, standardize, or we are in the process of standardize our test purposes for conformance and security testing at the ETSI. So this is something that is really interesting and also very great for us in the project. We have the standardization path where we, let's say, standardize our test purposes, so our test specifications for conformance tests and security tests. And on the other side, we, let's say, provide a kind of reference implementation for those standardizations on the Eclipse Foundation. Yeah, here you can see how it looked like, let's say, 1.5 years ago, about the landscape. So that's also why the industry came to us and wanted to make the project with us. We have some, let's say, conformance tests here in the OPC UA framework. Of course, we have something here on the network layer and on a physical layer, and also for IP4, 5, and 6. But there was nothing in the, let's say, typical IoT protocols like MQTT, CoAP. I mean, this is not a complete diagram for sure, but the reason why we just have MQTT and CoAP here is because these are the protocols we tackled first. So the same thing you can see here, it's more, let's say, industrial view. So we have here kind of automation pyramid. So all the traditional protocols provide standardized test cases and testware and certification and stuff. But if you want to, let's say, break this pyramid down and want to have just a distributed network, there was an empty space. So there was nothing there. And that was the main reason to initiate the IoT-Testware, because we wanted to fill this gap and also want to go up the layers and introduce and include more protocols and technologies. Okay, so this was just introduction, just that you understand where the IoT-Testware comes from, what are the motivations, challenges, and stuff. So let's talk about the IoT-Testware. As I said, we started with IoT protocols. So we see us 100% at the moment, 100% at the horizontal level. So we are talking about communication. because this is our, let's say, everyday business at Fraunhofer FOKUS. We are over 20 years in communication testing, and we see here also the let's say horizontal the horizontal line where we see the IoT testware. At the moment, we see also that we break it more and more down, so we are also going, let's say, over the horizon and see other parts we do, but this was the initial, let's say, thinking about the IoT testware. So what are we doing? So I said we have two parts. We have the standardization and we have the, let's say, implementation or the reference implementation. So we started with some kind of requirement for MQTT and Co-op first. Now we also included the OPC UA framework, but we take this requirement, and on the Etsy side we create test suite structure and test purposes. So we define what we want to test of the protocol, what is important, and let's say encapsulate test cases for that. Not implemented test cases, but let's say test specifications. These parts are, let's say, part of the standardization. So this will be standardized. This will be referred or can be referred by certification bodies. And this is, let's say, the track of the standardization. And then what we also included was in the abstract test suite. We used TDCN3 for that. We used it because of the reason that the TDCN3 language is highly dynamic, so we can make conformance tests. We can derive from those conformance tests security tests or performance tests, whatever. We will also see an example later. And then we can, so the abstract test suite, so the test cases in TDCN3 are, let's say, provided on the Eclipse platform. And with another Eclipse project, Eclipse Titan, it's a tool to, let's say, write your test cases in TDCN3 and compile them and run them. We have the executable test suite with some kind of report and logging for sure. And you can use it out of the box, let's say, to run tests against your devices. The good thing is if you like, or if in your company or in whatever, you can take the standardized test purposes and make your own reference implementation in, I don't know, Python, Java, whatever language you like. We just use TDCN3 because we are experienced with that. We see the benefits of this language, and I will show you a slide later. The fuzzing approach, that was the first, let's say, advantage that we see to use TDCN3, as I said. So in the slide before, I explained we have the abstract test suite, IoT testware, so the test cases in TDCN3. And we used the Eclipse Titan to run them, or to generate an executable test suite out of it. So now it was very easy for us to have those tests that are, let's say, conformance tests in this case, and derive fuzz tests out of it. So how we did it? We just let the test suite run against an SUT, in this case a Californium, and we sniffed, let's say, the messages with Wireshark, and the structure we exported in some format. In this case, it was JSON, but anyway, you can use whatever you want. This we took as input for another Eclipse project, Fazino. Fazino is a framework that generates fuzz tests for you in an easy way. You can say, just give me a string and generate as much data as possible randomly, or you give him a grammar and he will generate some fuzz data, whatever. So we used our packet structure as input for the Fazino library, and out of this it creates for us fuzz data that we could play back easily in the executable test suite. And from our conformance tests, we could, let's say, with ease create fuzz data. So this is actually one one nice advantage of the language of TDCN3, and also the first use case we had about our testware. Okay. Then we thought about, okay, now we have conformance tests with CoAP and MQTT. We have some fuzz tests, and now we thought about, okay, but no one actually just wants to run in an industry or whatever. No one wants to take just MQTT conformance tests, run it against a device, and then it's done. We saw that we need more. So what we actually did, we had a look what's available, open source, and we want to create, let's say, something that is a little bit more complex. So actually, we took software that was already available, and we put together our conformance tests and fuzz tests, and wanted to build a whole testing solution for IoT. And this is actually what the IoT testware is about. So we have our conformance tests. So we filled the gap that was there, or that were there some time ago. We had conformance tests, we standardized them, and now we put it all together with other software to make it easy, for example, to run conformance tests and security tests in one, let's say, process. And what else we can do with the IoT testware, my colleague Alex will now talk about. And yeah, Alex, it's your part. So I'll give it to you.
Thank you. So, we heard the theoretical part behind the IoT testware. We want just to show some kind of use cases we just envisioned on how we could use the testware. And the first one is just the implementation. So if you imagine some kind of an development life cycle of an implementation on a test, might be an MQTT broker or some kind of CoAP server. So usually you take your requirements from kind of specification. You run through your development lifecycle, and at the end you are just fine with your implementation. You have your unit tests, and mostly that's it. But one thing is just missing: the evaluation against your specification. So how conformant is your implementation against the test? And at this point, we just want to introduce the testware as some kind of an executable specification, which just can run against your implementation and give additional test cases for your implementation, which just gives you some kind of additional tests, which makes your product better at the end. Because if you imagine putting different implementations together might be difficult if they are not compliant to a standard or specification. At this point, the IoT testware might be quite useful, because you don't need to implement anything, because you have the specification and you have the testware. Just run it against and have just some kind of a report which tells you at which points you're not compliant to the specification. Of course, the next point is on the other side. If you're not implementing, let's say, MQTT, you might be interested in evaluating how good the chosen implementation is. And we did it and just tested at this point 4 different brokers, which are all of them open source, and all of them claim to be totally compliant to the standard, or mostly compliant. But it was quite difficult to choose between them and just distinguish which one is really compliant and which one not. So if you see, there are huge differences sometimes, and we have tested even more, where just totally different outputs. And what you can see is, if you check between the different versions, there might be also breaking changes which just break the compliance to the specification. Because if a specification gets difficult, it might be also difficult to stay compliant within the life cycle of a broker, for example. So what we see is like the bad one here made the biggest changes, updates, but didn't break any compliance rules, but might be on the dependent on the bad performance and on the first test. But if you look at the better ones, they did also perform worse on later versions than they did in the first version. So this might be also some kind of good indicator just to keep the quality during the life cycle of a product. And of course, as we said, the fuzzing approach, so what we could is using the IoT-Testware for security and robustness testing. So you could also imagine just introduce this step also in the development life cycle and do regular robustness tests on your product without any development, because we rely on the specification, so you might do it easily. And the next thing is, which is not really implemented yet, but as we're using Eclipse Titan, we have a pretty powerful tool which is called Eclipse Titan Riot, which gives us a load generator which relies on state machines. So you can just define a behavior with a state machine and just generate automatically load out of it. So we just plan to use this feature and generate load for the implementation under test, and just measure different kind of metrics on the IoT, and just having more parameters to evaluate the IoTs. So we could just not only rely on the conformance of an MQTT broker, for example, but also have some kind of metric to tell this one performs better on higher load than the other one. So you could at the end have some kind of a good overview about the whole performance, like performance behavior, the robustness of an MQTT broker, and the conformance. So this might be quite useful for industries. So if you imagine an Audi, if they take an MQTT broker, they don't want to just to experience the bad performance on high loads when it's implemented. So they want to know it before that. So same for us. So we also choose MQTT brokers and evaluate their performance beforehand. So, and of course, we prepared a little demo for our IoT-Testware, and just to summarize all the things we just explained. Before we start, just a short diagram on what we're going to show. So, as we've heard, we built the IoT-Testware, and on top of that, we just built some kind of web server, as we call it. And this web server just gives an easy entrance to use Titan Eclipse IoT-Testware, because the handling was quite painful in the beginning, because the tools are mostly pretty difficult to handle, and you need to learn them. So what we decided is to build a web server for that, and just to ease the usage of that. And of course, you don't need to install or something, or know pretty much about your SUT. There's a website, and it just tells you click here and that, and you get your report. And of course, we're gonna look at that. But before I start, and don't forget, so So that's the basic website, Testware. So we built just a website around it, but this one also includes the conformance test suites we just talked about. We have also the co-op test suite, and we plan also some test suite for OPC UA. And in this point, we might start with the test suite structure and test purposes at the end. So what we defined, so you don't need to, you might go to Etsy and just download all the PDFs and so on, but we also try to integrate the test purposes into the web server, so you don't need to go to different websites. You can just read your test purposes directly from here. So if you click on that, you might see there's a test objective which tells you what are we going to test. So what's the test purpose about? You have a reference to the specification itself. So if you want, if you don't trust this test, you can just open the specification and find exactly the points where we derive the test purpose from. And of course, you have some kind of an abstract description about the test purpose, which is also standardized Etsy language. And it just gives a good indicator what we're going to test about. And if we want to see that live, we could just take some random values and just simply take this test case. So it was the connect one, so the first test we had, and you can just simply run it. Okay, no internet. Okay, so here we see we have no internet, and I tried to test the public Eclipse broker, so but shouldn't be a problem because I have Mosquito also locally running, so we could try to run the test can against this one. So if we run it again, we just see the Mosquito broker just passed the test case, which is quite obvious, and we can now directly have a look on that. So we just see we sent a message which looked like that. So we program it in TDCN3, and the Mosquito broker just answers correctly because it's closed the network connection. Because what we derive is if you set the fixed header flags, the specification tells us this is an invalid package, you need to close the connection. So that was good. And we might also try another one, so which is also locally running, but this one is not Mosquito and it does not perform that good on to the specification. And if you run it, the Testware just tells you the broker obviously didn't close the network connection. And we have even more, so you can just go test by test and test your implementation against this requirements from the specification itself. Next thing might be if you want to have a look on back on your tests, we have some kind of history feature, which is just where we can just look and this one. So we might have a look on the configuration which is required by Titan. So we built this one. So we see the host name or IP of the SUT. We have the configuration here which we gave with the credentials, and of course the test case which we executed. So you can afterwards just check your tests. Of course, you have some kind of basic report generation, which just replicates the tests we have seen as a PDF. So you can have it afterwards printed out, do whatever you want with it. Or of course, TCP dumps, which are quite useful if you wanna just track your traffic on the wire afterwards. We also track it, and you can have a look on that after the test run. And sure, of course, on co-op, similar thing. You could think there was also co-op SUT running and just 3 tests and right. So the back on this IP there's co-op ton running, so which seems to perform this test cases quite well. And of course you can have also the same things like having reports generated, and the reports consist mainly out of things like that, which just tells you this is the test purpose, and on the test purpose you have a timestamp and all your test verdicts. So same thing on that, and we also plan to have the same thing on OPC UA afterwards. So which might just ensure the conformance of implementations. And according to the ETSI way of testing conformance and interoperability, this is just the first step of ensuring interoperability to the specification, and the next step would be just to test the interoperability, where we just stick together different implementations and just try look how they perform. And as we have seen in the presentation on MQTT and co-op, such things were just missing. I know that Eclipse just tried to have interop events on MQTT, which might be a good next step after having tested, or this might be a first step before going to interop tests, just having the conformance checked. And I'm pretty sure the conformance or the interoperability results will be much better if everybody just tests the conformance beforehand. So that's from my side, and I think the time is over.
We can also put the 5 minutes by to coffee.
Okay. So, thank you very much.